Hello grade 6, this is a video on writing a conclusion. The last video showed you, the one at the top here, shows you what to do with your data. So hopefully you have inserted a raw results table here, and then the processed one here that will have size of parachute or area of parachute and time, yeah? And then you should be able to insert a graph here. And then you're going to give an example of you processing the data. So in this results table up here, you have what I refer to as raw data, and this is processed data. So how did you get from here to here? For you, it's relatively straightforward. You found an average. Found an average of time to fall 3 meters. So just give me an example. Take the 1, 2, 3 data and show me, say, average time equals, you write the 1 plus the 2 plus the 3, and then you divide it by 3. And that equals, and then tell me what that number was. That number there should be going here, shouldn't it? What you also did, let me just clear myself some more space. What you also did is you found area of the parachute. So just show me how you did that. So that was using this data and this data, wasn't it? Yeah? The length by the width. Length multiplied by width, and that was, so write those numbers in, multiplied by this, and so that equals that answer, and that goes in there. So basically you're given an example of how you found your processed data. This here is for a 1, 2. The processed data is for a 3, 4. The graph is for a 5, 6. And then for the top marks, for the 7, 8, it's about you showing me how you did that. You're not just doing it, you're showing someone how you did it. Just one example of each. Then the last part of this is we need to write what we call a conclusion. We have to interpret the data. Let me just clear myself some space. So our data, when we look at the graph shows a straight line, doesn't it? I have a copy of the graph here, look. Yeah, we can see that it's a straight line. The graph shows a straight line of best fit going up. When the area is small, that's what this line means. When the area is small, the time oh, hang on, that graph is wrong, isn't it? Larger parachute takes longer. Oh no, when the area is small, the time is small. Yeah? For example, and then give me some data. So you'd say, for example, area of 0.28 gave a time of 5.7, yeah? For example, when area is 0.28, time is 5.7, I think it was, seconds. You get that from your data though, you look at your results. Whereas, when area is, and you give me some big numbers and time, so you give me like this bit of data here, this big number and this big number, whereas the first one was this one and this one, yeah? So you're saying a couple of things. You're saying that the graph is a straight line. You're telling me what that straight line means. And then you're giving some evidence to support it. Yeah? And then the last bit, so this bit here would be like a 1, 2. This bit here would be like a 3, 4. This bit here would be like a 5, 6. Our 7, 8 comes from explaining it. So we go back to our hypothesis and back to our background research and say, this is supported by the scientific explanation and then you give it. So you say something like, the idea that a large area has a large air resistance, it collides with more air particles as it falls, so it goes slower and takes more time. Yeah? You can even make reference to the fact you've calculated speeds, haven't you? And you've probably found that a big parachute has a small speed, so it'll take longer. I'm not going to say too much about this because this bit is for you to do. I've helped you here, and then I want you to try and do it. And this is all known as interpreting data, or most people write it as a conclusion. But the IB refer to it as interpreting data, because then it goes across all subjects, not just science. Yeah.